Welcome back to the Radio Hyperactivity channel. Today's video is the first in a multi-part series. The encoders on two of the beams at my club has never worked particularly well, and when we did some maintenance there after a particularly bad autumn storm that brought down one of them, I was running my mouth and saying that we should have an absolute position encoder instead of a relative position encoder. I don't know if you know what that means, but basically a relative position encoder is just something that will tell you I moved one step to the right and I moved one step to the left, and then the controller has to keep track of where the antenna is at any given time. And of course that way too easily loses steps and gets out of control, so you have to recalibrate it. And yep, being the loudmouth that I am, I expressed that this is so easy to create. It's a much smarter solution. So I figured I should put my money where my mouth is, as they say, and create some of this. And this is what we're looking at today. This is the first step on that journey. I've created some software and I've created an absolute position encoder. We'll look at the absolute position encoder today, but just to give you a little tease of what the software can do, what you can see on the screen now. It's basically it's to visualize the direction an antenna is pointing, and with some other useful information as well. Before we get into the build, let me show you some of the features of this system. First of all, it's an azimuthal map. I think this is called, it's a zoomable azimuthal map. So basically you can tell the application your coordinates, and it will draw this map where you are in the center of the world, and you can see all the directions for all the other countries around you. And by zoomable, that means you can change the zoom level. We're changing it now from 0.5 to, let's say, 0.2. which would be most interesting for more local contacts around Europe, in my case. In addition, you can have, let me just put this back to a little bit more of the world, back to 0.5. You can have the nighttime overlay, as you can see here. This is to aid in visualizing where you will find the gray line. And you can switch that off if you don't like to. Or you can leave it on. I prefer to have it on. I think that's always nice to know. Let's see, what else can you do? You can set the width of your beam. Let's see what it's currently set to. In here, it's set to 30 degrees. So if we have a narrower beam, a longer narrower beam, we can set it to, let's say, 15. And we will see that, yeah, I think I need to reload for that to take effect. But yeah, there we go. There we have the much narrower beam, if you're lucky enough to have a beam with a 15 degree beam width. Other things we can do, we can of course set our home position as degrees, latitude and longitude. What else is there? You can control the opacity of the night overlay and also of the sector. And you can select between kilometers or miles for distance. So let me show you what that distance is. Up in the top left corner, you see a distance, and that's the distance from the center of the map all the way through the edge of the map. So completely across the map will be twice that distance. You'll see here that that's 10,000 kilometers. So basically we're now seeing half of the world as a flat map. Also in the upper left corner, you can see the direction of the antenna and a clock, a continuously updating clock. I don't know how useful that is, but at least that tells you that the application is still responsive. That's why I put it there. Also, the unit we're going to build today, the absolute position encoder, it's got a built-in web interface. So you can connect to it and connect it to your wireless network. And that's also got a readout for the degrees. This is mostly useful for debugging, I would think. So if you think this is something you'd be interested in, then please stick around and let's get on with the build. To build this thing, we're going to need some 3D printed parts. This is of course only as an example of something to use as a sensor for rotation. However you decide to attach this to your rotor and your beam, that's up to you, but this is an example showing how to do it. To do this, we need a couple of 3D printed parts, ball bearing, and some heat set inserts. We're going to need some wire to attach it to the ESP32, and we're going to need one of these modules. I think it's the AS5600, I think it's called. and it comes with the little magnets that's polarized correctly. Let's see if I can zoom this in without too much glare. Is that possible? Here you can see the little board that we will attach to this 3D printed part. So let's start building. First of all, we need 8 heatset insets set. So let's warm up the soldering iron and get some of these out of the box. Let's see, that's 2, 4, 6, 8. That should be enough. And yeah, this is heating up nicely. So we will just, let's see, I need some tweezers to hold these while I set them. And let's start with the simplest ones. These are the ones around the edges. It's not really exciting video material, I think, but I will probably speed through some of this. Let's see if I can show you this. Should be possible to see. Yeah, you can probably see there's a bit of plastic flowing out where I put the heatset insets. So my solution to this is just take a knife and cut it away. I'd normally use my scalpel for this, but I've misplaced it. So I have new ones on order, happily. There we go. And the last one. Yep, the ones down here, I don't think we're going to need to do that to them. No, let's just leave them as is. Then we need to press this ball bearing into this part. I'm curious to see how difficult that's going to be. I'm hoping it's going to be easy. I think I'll try to use this hammer has a soft handle, so I'll just place that on top and try to verify that it's try to verify that it's level and give it a little this may be harder than I thought. Let's see. So again, give it a little yes. I think that worked. It's not completely level, but we can probably fix that by tapping it a little bit. That feels and looks. Let's see, are you seeing this? You see this? It looks quite solid, and absolutely no need for glue, which is excellent. So this as well has been made to, if you see, it's got a bit of a fillet. I don't know if you can see that on the stem of this. So ideally this should fit in here and stop just flush with the underside when you force it in a little bit carefully. So let's try that. I think that worked. Let's see if you can. Yes, it did. Most excellent, and yeah, glides very nicely. Last thing to do on this part before we start soldering wires to the sensor is to glue the little magnet into this hole. So I'll mix up some epoxy and I'll meet you back here. And here we go. And much in the same way as if you drop a slice of bread, it's always going to land with the buttered side down. I think it's the same principle that makes it impossible to mix the exact correct amount of epoxy, because I always get way too much or way too little. But let's see if we can get just some of it down into the hole here. That should be enough. And I want to clean up clean up the top surface before you put the magnet in. I do this with tweezers, but I don't think I have any ceramic tweezers, and this is of course a magnet, so I will do it manually. Once again, I'll clean this off. Ideally, this should be completely centered and completely flat. So let's see if does that look good? Come on, focus. There you go. Yeah, I think that looks all right. So we'll leave that to set. There should be some quick epoxy, and continue with soldering this one. Let's start with yeah, about a little more than 25 centimeters of cable. Should be enough. The interesting challenge here is that you only need 4 cables, but you need to connect it to 5 different places on the board here. VCC, ground, dir for direction, and clock and data for the I2C bus. So I will need to somehow attach one of these wires to both the direction pin and the ground pin. See if we can zoom you in for some of this work. Gonna be maybe a little bit more interesting to watch. Start by splitting this wire. Seeing this? Yes. That didn't really work well. Try again. There we go. And I'll start with the black one. We use the black one for the direction pin and the ground pin, I think. So we will cut that a little bit shorter than everyone else. Remove some isolation. No, can we do this with this? No, I don't think so. We'll have to do it the good old way with this. And we'll take the small cutoff, and we'll see if we can manage to get both of these into that hole and solder them there. So I have another idea. If I can get both of them through here. Come on. Very fiddly work. I was not expecting that, but it's all right. Get you through here with enough room to also, yeah. I'm gonna have to flatten this out a bit. If I can get you through there as well. I can just solder this on top of the last hole. It doesn't need to go through. See if we can manage to squeeze that in. And we can. So once again, let's try and solder this one. This is now the direction pin, because there was still an opening there. So let's see if we can get that soldered. I think we can. Yes. And I'll just place this, cut off most of that and just place it on top of the pad. Bit of solder on the tip, and see if we can just attach it to the underside. It's going to work as well, I think. A bit more solder, come on. Yeah, burnt my finger at least, so that's something. That looks very ugly, but acceptable. All right, let's see if we can, I don't know if the zoom is the right here. Yeah, we can live with that. And I figured maybe we'd use the red one for VCC. Let's easier to remember, so we'll prepare for that. And cut that round about here. And we go. And come on, carefully through that. Bend it a little bit on top so it doesn't fall back out, and hit it with some heat. Come on. There we go. That actually looked much nicer. So again, let's see. That's the VCC pin attached. The last two are the clock and data pins, and that's the two center ones on this end. So we'll cut these to an appropriate length. I'm guessing that's about here. Remove some insulation. Someone told me it's called, and that they're of course complete. Come on, completely correct. The Norwegian word for insulation and isolation, it's the same word, so it's very easy for Norwegians to mix these up. But what I'm removing is of course insulation. Here we go. Don't really care which one is green and which is blue. Just need to document it so we know when we start attaching the other end to the ESP32. So for now, I'll just focus on getting them through their respective holes. Bending them back so they don't fall out. And see if we can cooperate, please. See if we can solder them as well. A little bit more, yes, and this one. There we go. I think that's nice. And yeah, let's cut off some excess wire here. I don't think that's necessary, but it's going to make it look a little bit nicer. And with that, let's see, with that, we're actually finished with this part at least. There are other things that you can do with this chip. The out is an analog signal, so if you want to just attach it to an ADC, you can do that, or you can talk I2C to it to get the readings, which is what we're going to do. Next up, we'll attach it inside the box, but I think we have to wait for the glue on the magnet to set before we can continue that. So I'll meet you back here in about half an hour. Let's continue to get this thing connected to the ESP32. This is an ESP32 C3 Super Mini, it's called, this board. Let's have a look at it. See, yeah, it's a very nice and tiny board. Very small antenna, which is kind of a problem. So if you want to have some really good range with this, you might want to pick another ESP board. But it's going to be a topic for another day, I think. Let's for today, let's just get this connected up. We have here the pinout for the ESP unit. So let's place that like so, and we will try and figure this out. 5 volts and ground will go on the second and third topmost on the right side. Let me just split this up first. See if I can do a better job than the other end. There we go. So ground will be going, ooh, that's a very ground will be going the furthest up, so we'll remove some isolation on that, and we will cut a little bit of the red one because that's going to be on the next pin, and remove some isolation as well, and we can see that the clock and data are on the middle 2 pins on the left side. So let's see, what is clock? SCL is clock, and that's green. So the clock is supposed to be a little bit shorter than the blue one. So we'll cut that about there, and that about there. And yeah, this is all very much just experimental, but at least now we should have the wires at approximately the correct length. And we'll put some tin on them and then put them in the module. After that we will assemble the unit, and I think flashing the firmware will have to wait for the next video because this is getting long already. Come on, be nice. Yeah, try again. A little bit of tin? Nope. On all the wires. Ooh, that's not a little. It's more like, I think, I can't remember who said that, but someone said that there should be a word that's the opposite of a little, and that that word should be a lottle. I don't know, I think it's a good idea. Should be easier for non-English speakers to see the relation, but yeah, this is waffling. Clearly, this is waffling. Let's get these connected. First of all, we need the ground wire to go into the second topmost hole, and we will let's see, the 3.3 volts wire should go right next to it, so we'll put that in as well. Try and bend them. That was not comfortable. We'll bend them over to keep them in place while we solder them. These have this, I think it's called castellated edges, so it's a 1.5 hole. That means you can easily solder this on top of another PCB if you should want to. But you can also use that little notch to bend the wires into. So let's see. No, not as easy. Let's get some more weight on this and try again. Seems to be working. It looks nice with my eyesight. Let's see how it looks later on. Next one is, let's see, the furthest down. But yeah, you can still see this. That's the SCK, that's the clock. And again, we will double check here. Here it's annotated SCL, but that's okay. It's the clock. That's the green one, I think. Yeah, that's the green one. And the green one should go to the lowest of the center 2 holes. So that's there. And that means the data should go to the one on above it. Like so. Let's just bend these back out into the, I think it's called castellated. I can't remember. If I remember to check, and if I'm wrong, I'll try and do a screen overlay. Could easily forget that. Let's just double check. These are the 3 above and 3 below. That's correct. The top one, or the one closest to the USB, is the data. That's the blue. And the blue wire is connected to SDA, serial data. Yep, that looks all right. Let's solder it up, or at least try. That's one. And then that's the other. I think we can cut a little bit of the excess wire here. Like that. And then, yeah, there's one thing. I should have done this in the other direction. Since the antenna on this is really small and not very good, you want to try and avoid to have cables going under it. So instead of having the cables going this way, we'll just bend them over and have them go in this direction instead. I can't see that, but now you can. So basically the antenna is going to be free of floating wires around it. That's going to make the reception at least a little bit better. Probably still not brilliant. That should be all the soldering, so we can turn off the iron. We'll continue assembling this unit today, but we'll save the firmware update for another video. So, next up in assembling, can you see this? Yeah, I think you can. We need some, these are M3 by 10 millimeter screws. And we need a total of, let's see if that, no, that's not the right one. Need a total of 8. 4 for attaching the board inside, and another 4 for putting the unit together. So, just enter all of them to begin with, and then we will tighten them up progressively. I don't know if this IC is sensitive to tension on the board. Some ICs are, so to the extent possible, if you do tighten screws holding down. Oh, come on, these are not the right ones. All right. See, the problem here is with these screws. I can show you. These they will protrude on top, and there's no room for them in the top unit. So I need to use other screws for this. I actually knew that, but I forgot, so we'll remove them, and luckily I think I have some of what's needed. So I'll be back in a second. Let's see. What we need is, we could probably use these, or actually I think these. Let's see. We could probably get away with using these, but I think these are going to look nicer. So we'll try them. If I can find 3 more. Wasn't expecting that to be difficult, but hey. I'll do this off camera. Yeah, there wasn't a lot of them, but luckily the ones that were there were black, so it's a lot easier to find them in that box full of silver colored. I don't know what do you call that color? Silver colored screws, metal colored screws. So we'll see if this works better, and clearly I need to order some more. I think these are called button head screws for M3 10 millimeter. So maybe when I'm editing this, I shall take this as a reminder to go on AliExpress and order some more of these screws. Again, we'll just finger tight, and then we will tighten it up progressively to minimize the twist that we could get on the PCB otherwise. Not that I know this is important, but in case it is, then it's better safe than sorry scenario, I think. There we go, and then we'll just tighten them up ever so slightly. And let's see. Yeah, they disappear beneath the surface. That's good, as planned. So Last part to assemble is this one, and this is in fact made for exactly these screws, so I'll just enter the screws beforehand. And put this on. Of course, the direction of the magnetic field on the magnet is, well, it is possible to know, but I didn't make an effort to find that out and align that with this marking. So in the software for this, we will just have an offset for the amount of degrees the magnet is offset compared to the marking on the dial. But that's going to be another video. For today, we'll just assemble the hardware. Let's see. Nice and tight. And there we have it. That should be the, let's call it the sender unit for sending the absolute position of our antenna. Nice smooth motion, and yeah, pretty nice build, I think. So that's it for today. I'm not going to promise you when the next video is going to be, but it's should be pretty soon. If you find this interesting, if you want to see the continuation, we will put the firmware on this, and we will also talk about the software that you can run on your computer to get a nice display showing the degrees of the antenna. It's got a lot of interesting settings, like you can have the gray line on and off, or you can set the width of your beam, and of course your location, and a few other things I think are in that software thing. And to be honest, I'm having way too much fun creating the software, so there might be some more features even by the time I get around to creating that video. If you think this is interesting or would like to see how it turns out, then please consider subscribing. It's not going to be so long before we have the next update. If you liked the video, please consider giving me a thumbs up. That helps the channel. And also, please do leave a comment if you have either a question or a comment as to something I did that I should have done differently. I'm learning a lot from this, and if you leave it in a comment, then other viewers can learn from it as well. With that, I will just say until next time, thank you so much for watching.